Welcome back to another video. Today we'll be looking at similar shapes, IGCSE mathematics. So let's get started. Similar shapes are basically the exactly the same shape but with different sizes. When we are looking at similar shapes, there are three facts or three things that we must always remember. Corresponding angles of both the objects are of the same measure. The dimensions or the length and width increase or decrease by the same amount, and this same amount is called the scale factor. Similar shapes have same shape and properties. Properties such as angles, right? Okay, so they have given us two triangles. What they are telling us that um with these lines drawn, this shows us that angle A over here is the same angle as angle P over here. Angle B is the same angle as angle Q over here. And the same angle C is the same angle as angle R. And over here, what they're showing us that AB over PQ, so AB over PQ is the same as BC and QR, and AC and PR are the same. Why is it the same? Because when you divide this, you're calculating their scale factor. And because it's similar shape, scale factor will always be the same. So yes, object over image, we took the dimensions of our object divided by image to get our scale factor. Let's look at the example. We have 2 centimeter 3 centimeter rectangle A and 8 by 12 centimeter rectangle B. How do I find the scale factor? Usually what you're supposed to do is you take the big number and divide by the smaller number of the same length. So I can see that 2 centimeter over here and 8 centimeter here are like they are the same. 3 centimeter and 12 centimeter are all, oh, let's change colors. 3 centimeters and 12 centimeters are also of the same the correspondence. So what to find the scale factor, this is what we will do. 8 divided by 8 divided by 2, this gives us 4, and you add an x, that means times 4, and this is the scale factor. If you don't trust me, let's try for the other one. 12 divided by 3 also gives me 4, so times 4, and hence the scale factor is times 4. Now let's look at areas of similar shape. The relationship between the corresponding sides of similar figures and the areas of the figures is given by the statement scale factor of the area is scale factor of the length squared. Okay, because area is length times breadth and its units are, let's say, centimeter squared, that's why we are squaring it. We have an example. We have 5 by 4 triangle, 10 by 8 triangle. Find the scale factor of the area. So let me first find the scale factor of the length. That becomes 10. I see this are the same, so 10 over 5, that becomes times 2, and that's of the length. Scale factor of area is the same as scale factor of any length squared. So if I need to find this scale factor of length, this is 2 squared, which gives us 4. Right? That's the scale factor of the area. So if I told you the area of triangle A is what? Half times 4 times 5. That gives me 2 times 5, 10 centimeters squared. Then the area of this triangle, without calculating, I can tell it will be 40 centimeters because of the scale factor. Let's try it. Half times 8 times 10. That's half times 8 is 4. 4 times 10 is 40. See, that's how easy it is. Let's look at another example. Example 2. We have a side x and another side 22.5. This and this sides are the same, and we have been given the area. Now we are supposed to find the value. Let me write that. Find the value of x. So how what are we going to do? How are we going to go about it? So what we'll do is that we'll first write down the formula we know. Scale factor of area is equal to scale factor of one of the length squared, right? So scale factor of area, how will we know? First, let's write down this one. X over 22.5 squared. This is the scale factor of the length. And this is the same as area of this 135 all over 303.75. When you expand this, you get x squared over 22.5 squared equals to 135 over 303.75. The value of x would basically be square root of 22.5 squared times 135 over 303.75. Let's put that on our calculator and let's see what we get. What I got was x to be 15 centimeters. If I'm wrong, please make sure to correct me. I always say that, but the answer should be 15. Then we move on to the volume of similar shapes. Now, volume is the same as area, but this time it's to the power of 3 because why? We know volume is length times times width, and then centimeter cube, right? The cube, that's why it's to the power 3. We have an example. We have 5 centimeters of one length, 12 centimeters of another length. What's the volume? Let's say volume is, let's change the color. What, let's say, sorry, let's say volume is x. So we know that scale factor of volume is scale factor of length cube. So I need x over 288 times 5. Oops, not times. So 5 over 12 cube. Hence my x will be 288 times 5 cube all over 12 cube. And when you put that on your calculator, you should get 20.8. So because it's volume, it will be 20.8 centimeter cube. That should be our final answer. And I think that should be all for the video. We looked at similar shapes, the areas and volumes and everything around it. I think that should be it. Till see you in the next video. Till then, ta-da and bye.